Okay, in the integral of the day, we are integrating sec squared x over cosec squared x, and we're going to show that it can be written as tan x minus x plus c. Now, we've been doing quite a bit of work on trig and integration recently, but I can't immediately think of anything related to this. One thing that I do spot is that they're both these reciprocal functions, aren't they? So sec, because of the third letter c, this is 1 over cos squared then. And this one here, cosec, because I can see the third letter is s, this is 1 over sine squared. So here's what we're going to do. And we're going to try and do it in a way that makes it as not confusing as possible. So we're going to write it out with the division symbol first, because if you feel like there's going to be lots of fractions, that can be a good step. And now I'm going to write this as 1 over cos squared x. I'm just going to double check I'm happy with that. Yes. I'm going to keep the division for now, and then this is 1 over sine squared x. The next thing I'm going to do is I'm going to think about multiplying fractions. So I'm going to multiply instead by the reciprocal. So that's sine squared x, isn't it? Which means that this whole thing here becomes sine squared x over cos squared. And I'm sure some of you would have done that straight away, which is fantastic. But if not, that's not a problem. Now, a clever thing we can do here is we can, because they're both squared, instead of sort of doing it like that, we can rewrite it like that, because it gives you the same result, doesn't it? Why would you want to do that? Well, because then you can see sine over cos, and sine over cos is in fact tan. So all of this here actually turns into tan squared x, and that puts us really close to being able to finish the question. So it says show that it can be written as tan x minus x plus c. So the show that's there to guide us. Well, where does tan come from? Tan comes from having sec squared, doesn't it? And where does minus x come from? That comes from having minus 1. So there's a big clue for what we need to do. The final bit really is we need to just use our identities. So we've talked before in previous videos about tan squared being sec squared. So let's write that. So the integral of tan squared x is the same as the integral of sec squared x minus 1. Okay, and the integral of sec squared x minus 1 is in fact, as we just sort of said there, tan x minus x plus c. So it's quite an intimidating question to look at to start with. But there's a few things going on. Looking ahead at show that as a guide for what you need to do is useful. When you have fractions and you're worried that you're going to have fractions over fractions and so on, the division symbol can be quite helpful to make things less confusing. And we also had sort of rewriting tan squared as sec squared x minus 1. You can do something similar with cot squared as well. That this can be a useful step as well.